Welcome to the Explainer. So today we're looking at fetal development, but from a bit of an engineering perspective. I want you to imagine a construction site, but it's working on the most complex architecture in the known universe, the human body. Between the third week of life and birth, there's this incredibly intricate set of blueprints that guides the creation of all our internal plumbing and mechanics. But what happens when those blueprints go off script? Today, we're exploring pulmonary system congenital malformations. Basically, the structural anomalies that pop up when the early microscopic scaffolding of the human airway goes awry.
Okay, let's dive into this. Just to make sure we're all on the absolute same page here, a congenital malformation is, quite simply, a structural defect that's present right at birth. It's caused by an interruption or a glitch in normal fetal development. So we aren't talking about infections acquired after birth, right? We're talking about the basic biological hardware not forming quite the way it was originally designed to.
Think of our agenda for this explainer as a sort of anatomical itinerary. We'll start at the upper airway, looking at blocked passages, travel down the trachea to check out collapses and crossed wires, look at the diaphragm going out of bounds, and finally reach the lungs to see what happens when they're missing or underdeveloped before wrapping up with our key takeaways.
All right, Section 1. Let's move to our very first stop on this anatomical tour, the absolute entry point of air itself, the upper airway.
This brings us to a really fascinating condition called choanal atresia. I want you to think of this as a blocked intake vent. So between the 3rd and 7th embryonic weeks, the passages at the very back of the nasal cavity, those are the choanae, they're supposed to open up when a dividing membrane ruptures. But sometimes it just doesn't happen. Notice the difference we're looking at here. A unilateral blockage, so just on one side, often presents with a heavy, mucus-like discharge. But a bilateral blockage, that means both sides are sealed entirely shut.
And here's the crucial point. A bilateral blockage is an absolute immediate emergency. Why? Well, because newborns are what we call obligate nasal breathers. They literally don't know how to breathe through their mouths unless they're actively crying. No way around it. If a baby has bilateral choanal atresia, they are going to turn blue, a condition known as cyanosis, and this gets especially scary during feeding. The terrifying but honestly fascinating sensory reality here is that the baby's breathing only improves when they gasp or cry, because that forces the mouth open and temporarily relieves the obstruction. Oh, and keep in mind, up to half of children with this condition have other anomalies too, often linked to a genetic mutation known as CHARGE syndrome.
Moving on to Section 2, further down our anatomical map, we arrive at the trachea. This is the main pipe of the respiratory system, and it sometimes suffers from weak walls or, quite literally, crossed wires.
Now, what's really interesting about what we're looking at here is the stark visual contrast. On the left, a completely healthy trachea has these beautifully formed, rigid cartilage rings, keeping the airway wide open. But on the right, with tracheomalacia, that vital integrity is completely lost. The anterior cartilage is weak, which causes the posterior wall to literally collapse in on itself. The main pipe has just lost its structural reinforcement.
And as you can imagine, this mechanical failure leads directly to its primary, incredibly visceral symptom, expiratory stridor. Because the pipe is floppy, when the infant exhales, the airway narrows even further, and it creates this very distinct, high-pitched whistling or wheezing sound. And it definitely worsens during times of increased airflow, like when the baby is active, coughing, crying, or feeding, but when they finally rest, that stridor decreases.
But weak walls aren't the only tracheal issue we need to talk about. We also have those crossed wires, which are known medically as tracheoesophageal fistulas. And I really want to emphasize this huge number. Over 85% of these fistulas present in one very specific and highly dangerous configuration. And that configuration is esophageal atresia with a distal fistula. Just look at the early development happening in the 4th and 5th weeks. The esophagus, the food pipe, just ends blindly in a pouch. So the baby swallows milk, but it literally has nowhere to go, which leads to immediate drooling and regurgitation. Meanwhile, the lower part of the esophagus is mistakenly connected straight into the trachea. This means highly acidic stomach contents can dangerously backflow right into the lungs, which causes severe inflammation. Now, there are other, rarer variations where the plumbing gets even more chaotic. In an H-type fistula, for instance, both pipes form fully, but there's this rogue connecting tunnel right between them, meaning ingested milk can still leak into the lungs. Then there's a proximal fistula, where the upper esophagus connects directly to the trachea, basically dumping swallowed milk right into the airway.
And in some incredibly rare cases, both ends of a completely severed esophagus connect improperly to the airway. Each of these misconfigurations poses totally unique, severe risks for choking or massive lung inflammation.
Okay, moving to section 3. Let's continue our spatial tour down to the diaphragm to explore a fascinating yet dangerous domino effect in fetal development.
The diaphragm is basically the muscular floor of the chest cavity. It's supposed to separate the lungs and heart from the stomach and intestines. But if this protective barrier fails to form completely by the 12th week of gestation, you get a congenital diaphragmatic hernia. In really simple terms, a hole in the floor means crowded neighbors, and the anatomy gets incredibly chaotic.
Because the abdomen is naturally under pressure, a hole in the diaphragm essentially forces the abdominal contents upward right into the chest cavity, and this typically happens on the left side. Notice how the stomach and the large intestine have totally intruded into the space meant strictly for the left lung and the heart.
And this brilliantly illustrates the severe real-world impact of this intrusion. Looking at this X-ray, all those dark, bubbly pockets on the left side of the chest, yeah, that's the stomach and bowel, right where they absolutely shouldn't be. And look at the heart, that opaque white structure, it has been pushed completely out of its normal position and shoved way over into the right pleural cavity. The neighbors haven't just crowded the space, they've totally taken over the house.
Grounding this heavy anatomical shift in the reality of the patient, if you were a doctor examining a newborn with this condition, you'd immediately notice severe respiratory distress, and the baby might be turning blue with cyanosis. Listening with a stethoscope, the breath sounds on the left are incredibly diminished, and the heartbeat is completely displaced to the right. And visually, you'd see the baby's belly appears outwardly sunken or concave, what we call a scaphoid abdomen, simply because the intestines have vacated the area and moved up into the chest.
This brings us to section 4. We've finally arrived at our last destination, the lungs, our expansion chambers. Let's explore what happens when they are entirely missing or severely cramped.
So this is pulmonary agenesis. It's a rare condition where the blueprints for the lungs are just missing altogether. The initial lung bud simply fails to branch out. If it happens on both sides, it's obviously incompatible with life. But in a case of unilateral agenesis, just notice the massive empty void on the patient's left side. No bronchi, no alveoli, literally nothing. The remaining right lung has to dramatically hypertrophy or overgrow to sustain life, which shifts the heart and the mediastinum entirely over to fill that empty space.
Now, it's absolutely crucial to distinguish complete absence from pulmonary hypoplasia. Hypoplasia means the lung tissue is there, but its development was arrested, it's incomplete. It leaves the lung with a drastically reduced number of alveoli. This sort of maturation arrest usually happens when the normal mechanical stimuli of breathing in the womb are somehow interrupted.
Let's connect this directly back to our previous stop. Remember the diaphragmatic hernia? Those crowded neighbors literally squash the developing lung? Here, you can clearly see how the intrusive abdominal contents physically compress the fetal lung, stopping it from growing to its full size. Because the intestines took up all the available physical space, the lungs simply could not develop.
And the physical alterations of the newborn's entire chest cage really depend heavily on whether one or both lungs are underdeveloped. Unilateral hypoplasia results in a totally asymmetric chest, where one side expands differently than the other. But if the condition is bilateral, may be caused by a severe lack of amniotic fluid that restricts all fetal chest movement, the baby is born with a very distinct bell-shaped thoracic cage deformity and will suffer from shallow, rapid breathing and profound respiratory distress.
And with that, we're at section 5. We are wrapping up our top-down anatomical journey with some key takeaways and conclusions from the construction site.
So to quickly summarize what we've covered today, diagnosing these malformations is definitely tricky because they heavily share symptoms like dyspnea or difficulty breathing. However, there's a distinct clinical divide. Upper airway plumbing issues, like blocked nasal passages or certain fistulas, are very often surgically correctable, but the structural abscences in the lower tract, missing or fundamentally underdeveloped lungs, carry a much higher, often fatal risk. At the end of the day, these structural defects arise from a highly complex, often misunderstood interaction between genetic mutations and environmental factors during pregnancy.
Which leaves us with a final thought. The fact that the early microscopic scaffolding of the human body forms correctly millions of times a day is a literal marvel of biology. But with the intricate blueprints of human life still partially a mystery, what environmental risk factors will we uncover next that influence this delicate balance? Thank you for joining me on this explainer. Keep asking questions and keep exploring the incredible mechanics of the human body.